Okay, features of log and exponential functions. So we can see that this is a log graph, but also you can tell that because the asymptote is vertical. So this would be log and this would be vertical. A vertical asymptote is always going to be x equals a number. A horizontal asymptote will always be y equals a number. In this case, our vertical asymptote is at x equals 0. The range of a function, remember range is low to high. This function, you can see it keeps getting lower and lower. So negative infinity, and then it keeps getting higher and higher. So positive infinity. So we're going to say negative infinity to positive infinity. And then the domain is left to right. So the furthest to the left that this function goes is x equals 0. The furthest to the right this function goes is positive infinity. So its domain is from 0 to infinity. And if you start on 0 and head that direction, the function is always getting lower. So it is decreasing on its domain. The end behavior on the left side of the function. So here's the end on the left side. Here's the end on the right side. Okay, so as x is approaching 0, because that's as far left as it goes, so we would say x approaches 0 from the right side. The function is getting higher and higher, so y is approaching positive infinity. The end behavior on the right side, x is getting bigger and bigger and bigger and bigger, so x is approaching positive infinity. The y value is getting lower and lower, so y is approaching negative infinity. So here's another one. This is an exponential function instead, and you can see that it has a horizontal asymptote. So exponential and horizontal. And horizontal asymptotes are always y equals a number. In this case, that number is 3. And that also affects the range. So the lowest it goes is negative infinity. The highest it goes is 3. So the range is from negative infinity to 3. And then for the domain, we're looking left to right. So you can see that it keeps getting further to the left and it keeps going further to the right. So its domain is going to be all real numbers. So negative infinity to positive infinity. And if you start on the left and head to the right, this is always getting higher. So it is increasing on its domain. So you always start on the left side of the graph, go to the right side of the graph, and decide if that's increasing or decreasing. All right, the end behavior on the left side, this is the left side. X is getting bigger and bigger toward the negatives, so y is getting lower and lower. So as x is approaching negative infinity, y is also approaching negative infinity. The end behavior on the right side, x is getting bigger and bigger. So as x approaches positive infinity, y is getting closer and closer to 3. So y is approaching 3. Okay, so this section is graphing exponential and logarithmic functions. It's an exponential function if your x is in the exponent. And there's 2 points that you're going to always start with, and it shows you those 2 points on the graph. Those aren't the 2 points you start with, but it gives you 2 points to move around on the graph. For an exponential function, the first point is always, always, always going to be 0, 1, which is on the graph. The second function will be 1, comma, whatever the base is. Now, in this case, the base is 1/3. So if you want to stick with whole numbers, which we do, and actually it requires that we have whole number points, we're going to do -1 and then the reciprocal of the base. So in this case, it would be -1, 3. So we're going to move this point to -1, 3. If it were 3 to the x, then we would use positive 1, 3 as our second point, okay? And then an exponential function is always going to start with its asymptote at y equals 0. All right, now we may do some shifting and that may change, but we're always going to start at this point, and this asymptote. So once you do that, once you have that on your graph, delta mass should go ahead and graph that for you. And then we need to just shift and or stretch. Now a stretch would be multiplied times the base. And since we don't have anything multiplied times the base here, there's no stretch. But we do have two shifts. So the -8, that's where the x is going to be a left or right shift in the x direction. And remember, it is the opposite direction as what it says. So -8 means we're going to shift right 8. And then this big +1 is a y shift, an up or down shift, and it's going to be up 1. So we're going to take these 2 points that we already found, and we're going to shift each one right 8 and up 1. So this point that's at 0, 1 will shift to 8, 2. And the point that is at -1, 3 will shift to 7, 4. And then when you do that, your asymptote will also shift up 1 and be at y equals 1 now. If you shift it left or right, it won't really move because it's still side to side. But if you shift it up or down, that will move. Okay, so that graph right here, that's our final answer. So here's another exponential function because the x is in the exponent. So we know that the first point is going to be 0, 1. So that's right here. The second point will be 1 comma the base, which in this case is 3. So we'll move this point to 1, 3. And then we also know that the asymptote starts at y equals 0. So that's where you're always going to start your exponential functions. You're going to start with a point on 0, 1, a point on 1 comma whatever the base is, the base of the exponent, and then your asymptote at y equals 0. Now you always want to do your stretch next because a stretch is a multiplier. And then you want to do your shifts last, which is a addition or subtraction. So in this case, our stretch is -3. So we're going to multiply each y value by -3. If I multiply this by -3, it's still 0. So that's not moving. If I multiply this y value by -3, it would become 0, -3. So this point is going to move to here. And if I multiply this y value by -3, it will become 1, -9. So this point will move to here. So our exponential function is looking a little more like this now. Sorry, that's so wobbly. Okay, let me just try this again. There we go. Okay, next we need to do our shift. In this case, our shift is down 1 because it's a subtraction after the bulk of the function. So that's going to change our y values. So if we subtract 1 from our y's, that would become -4. This would become -10. So this point would move to here, this point would move to here. And then if we subtract 1 from the y value, our asymptote would also shift down 1. So this point would move to here, not point, asymptote. So overall, overall, the new function will look like this. So a little bit lower than the original function. For a logarithmic function, instead of our first point being at 0, 1, our first point will be at 1, 0, which is this point. And then instead of 1 comma base, it's going to be base comma 1. Our base here is 4, so that would be 4, 1. That's here. And instead of the asymptote being y equals 0, the asymptote is x equals 0, which means it is vertical. So we'll start it off here. After you get those first 2 points and asymptote in place, and again, it will always be 1 comma 0 and base comma 1 for a logarithmic function. Then we're going to do our stretch, which is the multiplier first. And then we're going to end with our shift, which is any adding and subtracting. And these rules are the same as exponents. So if we're going to stretch, we'll multiply that number by the y values. And then if we're going to shift, we'll add to the y values and or the x values, depending on what direction we're shifting. So in this case, our multiplier, our stretch, is just this -1. So it's going to shift our y values to a negative. So if I multiply this y value by a negative, it's going to stay the same. If I multiply this y value by a negative, it's going to change to -1. So this y value will move to -1. So now our graph would look like this. This is not a y value, so if I multiply it by -1, it wouldn't matter because it's not a y. Then we need to do our stretches. So we have a +1 that's on the outside of the function. That's going to be in the y direction. So it's going to shift up 1, or it's going to change our y's to +1. And then we have a +6 where the x is sort of on the inside of the function. That's going to shift it left 6. So your x values you're going to subtract 6 from. All right, so each point on our graph is going to shift up 1 and left 6. So this point right here, if I shift it up 1 and left 6, it would end up at 0, 2. Sorry, -2. And then this point, if I shift up 1 and left 6, it will end at -5, 1. Sorry, I wrote that backwards. It is at, hang on, I'm looking at the wrong ones. This is the one that I moved first. So I moved the point 4, -1 to -2, 0. 4 minus 6 is -2. -1 plus 1 is 0. And then this point, 1 minus 6 is -5, and 0 plus 1 is 1. And then the asymptote, we would also shift left 6. So that would move to x equals -6. And then you would see this function here. Okay, to find the inverse of a function, any function, you're going to take each point and you're going to switch the x and the y values. So this point, x is -1, y is 1. So my new point, x will be -1, sorry, x will be 1, y will be -1. Here it's -2, 2, so it's going to become 2, -2. -4, 3 will become 3, -4. And -8, 4 will become 4, -8. And they're always going to cross at this dotted line, y equals x. And then if you have a vertical asymptote like we do here at x equals 0, then that will switch to a horizontal asymptote y equals 0, because again, you're switching x and y. X equals 0 becomes y equals 0. All right, there is our graph. Now on the next slide, we have to state some information about this new function. So here's the new function that we graphed. Now we have the original function here. We need to find the inverse function, the new one that we graphed. So to do that, we're going to switch the x and the y in the original. So instead of y equals log 2 negative x plus 1, it's going to be x equals log 2 negative y plus 1. And then we need to solve for y. So to solve for y, this is a log equation. To solve for y, we need to get log by itself first. So we'll subtract the negative, or subtract the 1 over. And then once log is by itself, we can rewrite this in exponent form. So the base of our logarithm is the base of our exponent, and logs are always equal to the exponent. So x minus 1 is the exponent, and then this will be equal to negative y. And then to get at y by itself, we would just need to divide by negative 1, which would make this negative 2 x minus 1 to the x minus 1, excuse me. And you can see this, since it's upside down, that's what makes it negative. And then the minus 1 has shifted everything to the right one. Okay, it has a horizontal asymptote because the original asymptote was vertical, so the new asymptote is horizontal. So horizontal lines are y equals a number. In this case, it's 0. The range of the inverse function is low to high, so negative infinity to 0. And if you start on the left side and go toward the right, it's always decreasing. So this is decreasing on its domain, and it keeps going forever to the left and forever to the right. So its domain is negative infinity to infinity.